Expecting you to put it where the Sun is, it would unwind to the circle of Jupiter, a monster totally shaky and about to explode. It is among the most perceptible sources of radio energy in the entire universe, conveying more energy than a billion suns. Betelgeuse, or Betelgeuse, is a red giant star. If you placed it where the Sun is, it would extend to Jupiter's orbit. Massive, absolutely irregular, and also on the verge of explosion. When we think of stars, we often imagine tiny, twinkling lights in the night sky. From Earth, that's how they appear. But in reality, stars are something entirely different. Perhaps one of the most remarkable stars, Betelgeuse, is vastly more significant than our Sun. For years, this star has puzzled scientists. However, something even more alarming has been happening with Betelgeuse, leaving astronomers and other experts deeply concerned. Join us in this discussion as we explore the groundbreaking new data about Betelgeuse, its impending destruction as predicted by the James Webb Space Telescope, and how this event might impact our universe and life on Earth. As explained by physicist Michio Kaku, Betelgeuse is a cosmic wonder, a colossal star that has fascinated astronomers for ages. A Greek astronomer named Antonius was the first to identify it. This star is so enormous that it is visible in the night sky from Earth, especially during winter. If you're into astronomy, you've likely seen or heard of this star. The glowing orange-red star marks the upper left shoulder of the Orion constellation. This ancient star is one of the most extraordinary celestial bodies in the night sky. However, one notable characteristic of Betelgeuse is that its brightness is not constant. It fluctuates. This variation is one of its most remarkable properties, but it's not the only one. Let's examine some of Betelgeuse's key characteristics. Most of the stars we see in the night sky are extremely far from Earth. The closest star, Proxima Centauri, is 4.2 light-years away. To put this distance into perspective, imagine traveling at the speed of light for an entire year. Light moves at 186,000 miles per second, so the distance it covers in a year is about 5.88 trillion miles. That's 1 light-year. So when we say the closest star is 4.2 light-years away, it means it's billions of miles from Earth. Now, consider this. Some stars are even farther away, and Betelgeuse is one of them. It is located approximately 600 light-years from Earth. Even if we could travel at the speed of light, it would take 600 years to reach it. Since our fastest spacecraft can't even approach such speeds, Betelgeuse remains an incredibly distant, yet brilliant presence in our sky. If you're wondering how Betelgeuse can shine so brightly despite its distance, it's due to its immense size and luminosity. Betelgeuse is significantly larger than our Sun. Its radius is estimated to be hundreds of times greater than the Sun's. Unfortunately, it appears as a blurry disk in space when observed through current telescopes, whereas most stars appear as small points of light. This effect is likely due to the turbulent reactions occurring in its outer layers. In terms of mass, Betelgeuse is estimated to be around 12 to 19 solar masses. A solar mass is the standard unit used by astronomers, where one solar mass equals about 2 times 10 superscript 3 kg. Scientists struggle to determine Betelgeuse's exact mass because there are no planetary bodies orbiting it for direct comparison, and, of course, we can't measure it directly from Earth. Nevertheless, we know Betelgeuse is many times more massive than our Sun. Betelgeuse's brightness fluctuates between magnitude plus 0.0 and plus 1.6. In simpler terms, it is typically much brighter than our Sun, hence its nickname, the Red Giant. However, its brightness is not stable. It varies due to its pulsations. Betelgeuse expands and contracts, and when it expands it becomes brighter, whereas when it contracts it dims. This cycle can last anywhere from 10 to 100 days, sometimes even longer. A unique feature of Betelgeuse is that its surface is covered in dark magnetic spots. The magnetic field in these spots is far stronger than the regular surface, but it also disrupts the flow of hot gas, making these regions cooler. Because Betelgeuse has so many of these spots compared to our Sun, it appears cooler, despite being far more massive and luminous. The Sun also has dark magnetic spots, but those on Betelgeuse are much larger and far more numerous. To put it in perspective, the spots on Betelgeuse can be twice the size of Earth. Additionally, Betelgeuse possesses a magnetic field that is several times stronger than the Sun's. This magnetic activity causes the gases in its outer layers to appear swirling and twisting when viewed through telescopes. Betelgeuse's surface temperature is approximately 3,500 K. This relatively low temperature contributes to its lower energy output and red color. Interestingly, Betelgeuse was not always red. About 2,000 years ago, it was yellowish, similar to our Sun. Over time, its color changed to orange-red, and around 1,000 years ago, it transitioned to the deep red hue we see today. This color shift suggests that Betelgeuse is undergoing significant changes. It produces hundreds of thousands of times more energy than the Sun, and if it were closer to Earth, it would be a dominant celestial body in our sky. Despite being 600 light-years away, Betelgeuse is still visible to the naked eye at night, which is astonishing. Our Sun, in comparison, is only 8.3 light-minutes away, which is why it appears so bright. If Betelgeuse were much closer, we would see it even during the daytime. However, if Betelgeuse were to replace the Sun, it would engulf Mercury, Venus, Earth, and even Mars, extending all the way to Jupiter's orbit. The Sun, it would drink or uproot the Earth and the other 4 planets close to it due to its gigantic size. Otherwise, whether it were to match the Sun in size, it would, in any case, deliver more radiation. Betelgeuse, also called bug juice, is an exceptionally massive star situated in the constellation Orion, around 600 light-years from Earth. Its tremendous size is possibly one of its most striking features. It is commonly greater than our Sun in terms of radius and could easily envelop the orbit of Jupiter if placed at the center of our solar system. This incredible size allows Betelgeuse to appear as a disk rather than a point of light when viewed through powerful telescopes. Unlike most other stars, despite its enormous size, Betelgeuse is not the most massive star. Its mass ranges from around 12 to 20 times that of the Sun. This variation in mass estimates is due to the difficulties in precisely measuring the mass of stars that lack companion stars or other objects to provide gravitational reference points. In fact, even at its lower estimated mass, Betelgeuse remains a gigantic celestial body. The brightness of Betelgeuse is another key characteristic. It fluctuates consistently over time, with its brightness ranging from magnitude 0 to plus 1.6. For comparison, a magnitude 0 star is about 2.5 times brighter than a magnitude plus 1 star. At its brightest, Betelgeuse can ultimately be thousands of times more luminous than our Sun. This variation is attributed to its pulsations, irregular expansions and contractions caused by internal cycles within the star. When Betelgeuse expands, it becomes brighter. When it contracts, it dims. These pulsations can last for long periods, adding to its dynamic appearance in the night sky. Betelgeuse's surface temperature is relatively low for such a large star, measuring around 3,500 K. This gives it a distinctive red color, typical of red giant stars nearing the end of their life cycles. Like other red giants, Betelgeuse is in the late stages of stellar evolution. It has exhausted the hydrogen fuel in its core and has begun fusing heavier elements. This fusion process generates energy and causes the star to expand outward. The star's atmosphere exhibits complex physical phenomena, displaying dark magnetic spots on its surface where the magnetic field is stronger than the surrounding regions. These spots prevent heat convection, leading to cooler areas on the surface. Despite these cooler spots, Betelgeuse remains a massive, brilliant star. However, it will eventually meet its end in a spectacular cosmic explosion. Betelgeuse is a massive star nearing the end of its life, and its potential fate will be dramatic. When it runs out of fuel, it will undergo an extreme process of fusion, forming heavier elements like helium and carbon. This will cause the star to expand even further, possibly making it one of the largest stars in the night sky before it dies in a breathtaking explosion. A supernova. The power of a supernova is strong enough to outshine an entire galaxy for a short period. This event could even send shock waves through space, and it is possible that Betelgeuse will experience such a violent end very soon. While this fate is not imminent, scientists are closely studying the star to learn more about stellar evolution and the universe's structure. As Betelgeuse approaches the end of its stellar life, Astronomers are paying close attention to its behavior. The star is expected to go supernova eventually, an explosive event that will result in the ejection of its outer layers into space, leaving behind a dense core. This core could become a neutron star or collapse further into a black hole, depending on its mass. A supernova is a catastrophic event in a star's life cycle, marking the final stages of its evolution. Betelgeuse's potential supernova could be visible from Earth without a telescope, given its immense brightness and relative proximity. This explosion would release vast amounts of energy, creating heavy elements like iron and nickel, which are essential for the formation of planets and other celestial bodies. These elements would be scattered throughout the universe, enriching the interstellar medium and contributing to the creation of future generations of stars and planets. Interestingly, scientists have detected unusual changes in Betelgeuse's brightness in recent years, leading to speculation that the star could be nearing the threshold of a supernova. However, despite these fluctuations, it is difficult to predict exactly when the star will explode. Some researchers suggest that Betelgeuse could go supernova within the next 100,000 years. A brief moment in the universe's lifetime, but too far away to determine precisely. The James Webb Space Telescope, JWST, has provided new insights into the star's behavior. Its infrared capabilities allow scientists to study Betelgeuse's outer layers and magnetic fields in unprecedented detail. JWST's findings have confirmed the star's ongoing changes, including its irregular brightness and potential instability. These observations provide valuable information about the processes leading up to a star's death, offering a better understanding of stellar evolution. Betelgeuse's demise will have significant implications for the universe. The supernova's shockwave could trigger the formation of new stars in the surrounding region, facilitating the cycle of stellar birth and death. Additionally, the elements produced by the explosion will spread throughout space, contributing to the building blocks of new planetary systems. In the grand scheme of cosmic evolution, the death of Betelgeuse will not only mark the end of one of the largest stars we can observe but will also pave the way for the next generation of celestial objects. Although we won't be around to witness the star's final moments, studying Betelgeuse provides invaluable insights into the life cycles of stars and the dynamic nature of the universe. The research conducted on this star helps astronomers better understand the processes that govern stellar birth, life, and death. It also offers a glimpse into the fate of other stars that share similar characteristics. In the future, scientists hope to continue studying Betelgeuse using cutting-edge technologies and space observatories. The data collected from the star will continue to shape our understanding of astrophysics, helping us unlock the mysteries of how stars evolve and how their violent deaths impact the universe. Ultimately, Betelgeuse, as a massive and dynamic star, is a crucial part of the cosmic puzzle, and its eventual destruction will be one of the most captivating events in the history of our universe. While Betelgeuse's death is inevitable, it's important to remember that the universe is constantly changing and evolving. New stars are born every day, and the energy released by supernovae like Betelgeuse will ensure that the cycle of life and death in the universe continues. The legacy of Betelgeuse will live on, not only in the elements it creates but also in the knowledge it has provided to generations of astronomers and scientists. By studying stars like Betelgeuse, we can continue to unravel the mysteries of our universe, learning more about the forces at work in space and our place within it. As we learn from these cosmic giants, we are reminded of the vastness and complexity of the universe and the extraordinary processes that shape the cosmos we call home.